The designation MAP kinase, abbreviated MAPK, originates from one of the first members of this protein family, the mitogen-activated protein kinase, membrane-bound receptor of the family of receptor tyrosine kinases, phosphorylation of itself and also of the other subunit. Next, the growth factor receptor-bound protein 2, GRAP2 for short, can bind to the phosphorylated RTK. The protein SOS, named after its homologue son of sevenless in Drosophila, is able to bind to the membrane-bound protein Ras. GTP against GTP, guanosine triphosphate. This exchange leads to the activation of the Ras protein. In its active GTP, most important effectors of Ras. Active BRAF phosphorylates and activates the kinases MEK1 and 2, which in turn phosphorylate and activate the kinases ERK1 and 2. Finally, the kinase cascade leads to the activation of transcription factors of the AP1 family. Move to the cell nucleus, where they form a heterodimer and bind to an AP1 motif of the DNA. As a direct consequence, cell proliferation is activated. Also known as GAP. GAP binds to Ras GTP and increases this activation by providing a domain that assists the Ras protein in the P is hydrolyzed to GDP. GDP-bound Ras is no longer active and can no longer bind to BRAF. As a result, the MAPK signaling pathway is turned off. Mutation of the Ras gene GAP. GAP can still bind to mutated Ras in its GTP-bound form. However, GAP is not able to provide the domain that is crucial for the activation of the Ras. Activates an increasing number of MEK1 and 2 proteins. In turn, MEK1 and 2 activate ERK1 and 2, which activate Jun and Phos. Thus, the kinase cascade is not turned off. A permanently activated MAP kinase signaling pathway results in continuously activated proliferation, which is an important feature of a tumor cell.